Okay, welcome along. You just caught me there in the middle of some work here, in the middle of synthesizing exact, accurate wording. So we're doing Construction 7, where we divide a line segment. I'll give you an example, but you're not allowed to use measuring. So you divide, say, 12, which just happens to be the line segment, but you don't need to know the length of it, into a fixed number, 4 or 3. Well, we've done 2 to 3 for Construction 6, so 4 or more. So that'll be an example of 4. Here 15 broken into 3 centimeters each, where I'm being a little bit lazy about the units. Okay, so in particular we want to be able to divide a line segment into 4 or more equal. And when I say equal, I mean equal in measure, because the only thing you can do with a line segment is measure it. 4 or more equal line segments. Okay, you can say what direction it's going in, but it's irrelevant. 4 or more equal line segments. That's what we're trying to do without. That's the sting, without measurement. That's cool. And measurement was a big issue back in Euclid's time, because there was no standardization whatsoever, and there was very few particular equipment would be standardized like what we have now. So a rope with knots in it, first of all, they may not be equally spaced. They do their best to put them equally spaced, but measurement was a big issue back in the Greeks' times and before. But they had their ways around it, and they had very clever ways around it. They were able to make up their own units every single time. So let's see what it should look like. So it should look like an arbitrary length, but even though it's arbitrary, I'm going to start off each time in my copybook here with the margin. I'm also going to work from the bottom of the page, because it's basically all happening above your line, your working line. So construct a working line segment, and it's not a working line, it's a working line segment. The distinction being it should have a very clear end. You should keep your pencil going until you particularly stop, and maybe do a little twist there to show the end point. Okay. We go in an arbitrary direction, but over time we're going to find that less than 45 degrees is particularly handy. You'll see why shortly, and I'll talk to you about why. You start this, bring your ruler right up as far as you can, and don't be mean here. Keep going right out to the end. Okay. Keep this short, because we're going to have to put in a lot of them, 4 or 5 in an exam. We'll start off with a 4. 1 should be, you should only touch the compass at the tip top. 2, 3, and 4. Okay, then you should bring in your beveled set square. Okay, we're going to use this length. Look how that aligns. I'm going to stay well down and barely make this come up. Now I'm going to be going in that direction. You can do a trial run. Okay, so this is going to go through here and here, and you'll have already done Construction 6, so you kind of know what it's about. You just need to be kind of fast. Do a trial run all the way up there to the far end. Okay, and it just about works out. To watch my beveling here, I need to press it right down because of the way the pages are going. Okay, that's a practicality that won't happen in an exam. I'm trying to think, is there any way around that? Well, look, we'll worry about that when we get to it. I might do a piecewise thing with a separate protractor. That's a tiny practical thing that's of no importance, and I'm just doing this in a copy because I want it to be practical for you at home to do your homework. But in reality, you'll be using a sheet of paper, and there'd be a blank sheet of paper in the exam. They'd leave all the boxes out of it, because after all, boxes are really rulers, and you're not allowed to use rulers. So what makes it tedious is you've so many of these to do. And you might have seen there, I'm not too sure, if you any time lose this, ruin the whole thing, you can go back to the beginning, measure up your line up again, here I have an idea. I keep this so that it, look, there's a clever idea. Just given the particular restrictions I have, I'll go to there, because this can shoot out up beyond. So that's aligned, that's of course aligned, and here we come to the third one, which is now aligned. Very practical little problem. And we have this equals this equals this equals this, and because of the similar triangles, the similar angles and everything, we can say that this equals this equals this equals this. But not only can we say it, we can say, well, in the real modern world we do have a ruler. We can verify it. Now this won't be asked to you in the exam because it kind of defeats the whole policy and principle and spirit of it, where these lengths are equal, full stop. If you did your method right, you don't need a ruler. And if you were making a shelf or something, they would look lovely, they'd be spread out equally, and you never need to know what they measure. Nevertheless, that's 30. Of course I don't have to lift the thing. From 3 to 6 is 30. And when you say from 6 to 9, that's 3, sir, that's not 30. Well, yes and no, but it's 30 mil. And if you use mil, you often don't need decimal places. Okay. Now, this is a higher level only setup, so I think I'll leave it at that. You can, so I'll just say to you, get you started maybe on one. You can just practice these with a blank copy and your construction kit anytime you want. And you should practice coming back and doing it from scratch every few weeks, because it's therapeutic, number one, and apart from that, you guarantee you're learning and you're very, very confident going forward. So you draw any given line. I did a 5 there. No, was it a 4 or a 5? Let's look back. We'll go for a 5 this time. 1, 2, 3, 4. Okay, so we'll go for a 5 this time. Sometimes you want to do a dummy run up along to see could you get 5, but I can kind of eyeball that and say I'll never get there. But 1, 2, 3, 4, the moment of truth, 5, not quite, but that's okay, I can extend. 5. Now, end point to end point. And one thing that we're learning here is that you really want a bigger set square and as well in your pencil case, and these are very small, are very handy to do nearly everything you want, but we'll want a slightly bigger one as well. So I'll leave this and this demo because just as it is, and as it is, despite the fact that I have, as you know, very well equipped, don't have it with me right now. So I'll leave the rest of that to when you'd have a bigger set square sliding along, and this problem in the middle of the copy is a problem. Incidentally, just on a few session now, I've filled in all of these using constructions. So this is 24 cents worth of a copy. Don't be mean on the paper when you're doing constructions. Okay, that's construction 7 done.